Hey guys, I'm really hoping your studies are going well. My name is Saria Theophilus Dube, and I'd like to welcome you to this beautiful lab that we are going to be working on here today. So, at the end of the lab, we'll be configuring routing protocol EIGRP. So basically, we're going to introduce EIGRP on the network to have all of our LAN networks talking to each other. It's another routing protocol and is very robust. So in enterprise networks, it's normally deployed. So I've taken the time to do some color coding for a better understanding. So what we do have here is we're not using VLANs, though we are using separate LANs, individual LANs on the network instead of using VLANs. So what I do have here is the 192.168.1.0/24 network. I also introduce our server, and this is our DHCP server for this LAN. The same goes for this LAN network. We also have our server here, and I will also introduce a server on this LAN before we will go ahead to configure router EIGRP. So basically, it's just a simple network configuration, having enable anything basically. Having configured security parameters on the router yet. Now have I do anything with the switches as well. So the at the end of the day, the key takeaway is how to configure EIGRP. So let's add a couple of servers that's going to serve for DHCP server on this network and on this LAN network as well. So let's do that, and then we'll go ahead and configure EIGRP. So just gonna put this server right here, and I'm gonna pull this up. There you go. So I'm just gonna place this in here, and it's gonna be on the CLAN network as this PC. So we want to do cables. I'm gonna do a couple straight through, and you want to put it on the fast Ethernet interface of the server. I want to do port number 2 on the switch. Okay, and then next you want to go into the server and do some basic configuration. So to give you an understanding of what I'm going to do is, this network area is the 192.168.3.0/24 network. So basically I'm going to configure this server so any PCs that's going to be joining this network will pull their IP addresses off this server. So as you may remember, a /24 does have 255 IP addresses, 2 of which are not assignable. So one for network and one for broadcast, and we're going to configure the last 2 IP addresses in this network, which one is going to be for the DHCP server and one is going to be for the DNS server. I will configure the DNS server at a later date, but let's go ahead and give our DHCP server an IP address from this network right here. So we want to assign an IP server, a DHCP server with a static IP address, because you don't want your IP addresses changing from a resource on the network. So we want to do it 192.168.3.254. 255, that's the correct subnet max, and our gateway is going to be 192.168.3.1. Like I said, our DNS server is going to be 192.168.3.253. Okay, now this is the last available IP in this subnet, and this is the first available IP in the subnet, which is going to serve as our DHCP, as our gateway to the router or to the network, if you will. And this is second to the next IP address in the subnet, which is going to serve as our DHCP server, DNS server. So this is the subnet mask. So let's close this. Next, you want to go to services. You want to select DHCP. You first want to turn this on, and since this is just going to be the LAN server, you can leave these parameters. It just doesn't matter. You can leave the name as server pool. That will work just fine. So for the default gateway, we want to indicate our default gateway for the LAN network. So it's going to be 192.168.3.1, and like I said, the DNS server is going to be 192.168.3.253. If you remember, that's the same server address we gave to our DHCP in IP settings. Next, you want to create a stack of, you want to exclude a stack of addresses that you may want to assign statically at a later date. So I'm just going to leave this at 10. So basically, our first available IP address, that is right here, is going to be 192.168.3.11 and going up. All right, we can say 512. 512 is correct, but I like to do 200 users. Okay, you want to save, and you want to close this out. Basically, that's it. So you give a pool name. So the pool name is locally significant because that is meant for traceability, basically. Next, we want to give a default gateway. The default gateway is derived from what is assigned on the router assigned to the network. Okay, so this is at the edge network, the edge router for this LAN network. So the default gateway that's going to be assigned at the FOO interface, that's what you want to indicate here. Next, DNS server. I'm going to configure a DNS server from one of these services right here, and I'm going to give this DNS server the 253 IP address, but that will be at a later date. Next, you want to indicate this beginning IP that the DHCP server is going to dish out to clients on the network. So in my case, my first available IP address is .11. Because I have excluded 192.168.3.10. So the next available IP address is .11. Alright, so let's close this. Next, this switch is serving as a dummy switch, so it's going to be basically an unmanaged switch. You can go ahead and manage it, but it wouldn't mean well anyways. But what you want to do, you want to go on the router and then turn on that interface. So what we're going to do here is enable conf-t, and then you want to turn on this FOO interface and give it an assigned an IP address, which is going to be the default gateway of the LAN. Alright, so we want to do intf80/0. you do enter. IPR. The IP address that goes on this interface is the gateway to the LAN network, so it's going to be 192.168.3.1. if you remember, that's the gateway we set aside for our LAN network. Next, you want to do 255.255.255.0. this is a subnet mask for /24 network. You want to do enter. You could do description on this interface, but it's not necessary. You want to do no short, and like the director said, up down line protocol on interface, change state to up. So that is okay. Let's do fast forward. Next, you want to go on the app on the client PC. You want to go to desktop, IP configuration, and you want to take DHCP. So basically what is happening here is we are requesting an IP address from our DHCP server, which is part of our LAN network. Alright, so as you can see here, 192.168.3.10, okay, is our first available IP address. 255.255.255.255.0 is for /24. Our default gateway is 192.168.3.1, which is at the F000 interface of the router. And now our DNS server is 192.168.3.253, which we indicated. So if we were to add an additional PC to this network and just stick in the DHCP for IP settings, that client will pull its IP address from this server. Let's now configure our final server here, and then we'll go ahead and configure rather EIGRP to enable inter-network routing. So let's do this right here very quickly. You want to put a cable on that. So we want to use a copper straight through on the F0 interface. So you want to go on the F00 interface, and then you want to do the next available port here is port 2. Alright, next you want to go on the server. As you can see, this is the .4 network, so it's 192.168.4.0/24. So you want to first set aside the IP address for your DHCP server. So we want to do 192.168.4.254. That's the last IP address within the subnet. Alright, 255, that is correct. We want to indicate a default gateway 192.168.4.1. I like to use the 1 because it's easy for traceability and for troubleshooting. At least you're going to know which default gateway, which IP address is serving as a default gateway. Next, we want to do 192.168.4.253. This is going to be our DNS server IP address. So we're just going to give it to our router, to our DHCP server for now, and we'll configure the DNS server at a later date. We will just use the same IP address. So this looks great. 255.0, 192.164.1, 192.164.253. Okay, next we're going to move to the DHCP server in services, and then you want to go DHCP. You want to turn it on first. The name is okay. Now you want to indicate the default gateway, which is the same that you earlier on put in the IP services of the DHCP server. So we want to do 192.168.4.1. okay, DNS server, the same IP address, 192.168.4.253. Next, start IP address .10. Subnet max is correct, and let's do 200. So we are assuming we're going to have 200 users on this network. So basically that's a lot of IP addressing, and for maybe that entire block of the building. So let's do save, and then that is on. Finally, you want to go on the router. Okay, you want to go on the router to place in the gateway for this LAN network. So we want to do this. We want to do no, do enter, enable conft. Then you want to do intf0/0 interface IP add. So the IP address for the interface facing the LAN is always the default gateway, except where when you have sub interfaces, then you wouldn't have to assign an IP address to that interface. But let's do 192.168.4.1, 255.255.255.0. Do enter. I want to do no shot. That should be up. Okay, you want to close this and do fast forward, and then if we come right in here, you go to desktop IP configuration, DHCP, we should have our IP address from our DHCP server. Like you see, DHCP request is successful. That is good news. So 192.168.10, that is our first available IP address. 255.255.255.0, that's the subnet max. 192.168.4.1, that's for the default gateway, and right there indicated is our DNS server address right here. So that is all good. Okay, next we are going to configure IP addresses on our point-to-point links, and then finally we're going to enable EIGRP. This is also pretty easy. You just want to do it little by little and be very meticulous about it. So let's first test our connectivity and see whether we can ping to our default gateway. This should be successful basically, so that shouldn't be a problem. That is successful. Now we can route to other lanes because there's not a routing protocol. So if I ping here, it's going to fail, which of course it's supposed to, but we can all ping our gateway. Alright, until you can introduce an IP routing protocol before you have communications across the link. Okay, if you had VLANs here, of course with the introduction of this router, they will be able to communicate. That is called inter-VLAN communication, because made possible by way of this router. But if you have separate lanes network and you want to talk across another network, you have to introduce a routing protocol. So that's why this is very, very important in the real world. So let's configure our router interfaces, and then we'll enable EIGRP. How is that? This should be pretty easy to do. So let's start at router 1. So we're going to configure this link first on router 1, and then this link on router 2. So let's do this way. I'm going to do enter, enable config. So for this interface right here, our network is right here. Okay, so this is our network for this link. Okay, the same for this link, the same for this link, and this is for this link, and these are all /30 IP addresses. So this should be just fine. Okay, so let's go back in here, and so we want to do, like I said, I haven't configured any parameters, security parameters for the routers, because I want to focus on this EIGRP configuration before we run out of time. So let's do ITSE 0. You want to indicate the interface you want to talk to. Basically, that's what you want to do first. So now we are entering the 001 interface. So we do enter. We should do IP add 10.10.10. Okay, now the IP address here, the first available IP address is 13, the next is 14. Alright, you have to really understand that, because 12 is the network. That's what's going to be in the EIGRP statement. 12 is the network. So 13 and 14 are the assignable IP addresses. So we want to do 10.10.10.13 255.255.255.252. This is a /30 network. Okay, we do enter, and we want to do basically no short. So we're just going to focus basically on the EIGRP parameters. So we're just going to ignore other configurations that but there are a lot of parameters that you can configure within the interface mode of the router, but we're just going to ignore that. So next I want to shut this down, and in order to be very meticulous, let's do this. So we want to do .13 and .14. okay, so this is our point 13 right here. This will be .14 on the same network. Alright, so let's do this and see what happened to the interface. Come on, man. So you want to do intse 0/0.0. Oh, okay, this is 001 interface, so that's where you want to assign the next IP address. So we're going to do just that. 001, you do enter. I'm going to do IP add. The next IP for this link, it has to come from this network because this is the point-to-point. all right, so 10.10.10.14 255 252. okay, do enter. You can see right here, this link is our clock rate link, so this is basically the DCE. So you could do that. You could also set the clock rate for this interface. So you want to do clock rate 64,000. okay, then you want to do no short and see what happened to the interface. It's supposed to come up, which it does. Okay, that is good. Life is okay. Next, you want to come here and enable this link between R1 and R2. You could do it any other way, but you don't want to be bouncing around like that. It's going to be confusing a little bit, so you want to do that step by step. So let's do this link, and then this link, and then this link. We should be fine. All right, so now we are back on R1. So we want to do enter. Next, you want to go into this interface because that's the link you want to work with. Okay, intse 0/0/0. You do enter. The IP address is going to come from this range. So basically, for this network, we want to do .1 .2. all right, so 10.10.10.0 is the network. So the first IP address here is .1, which gonna go on R1. The next gonna go on R2. okay, these are all /30 point-to-point links. So we want to do IP add 10.10.10.1 255.255.252. okay, we want to do enter. As you can see, this is also the clock rate interface for router 1. So we do clock rate 64,000. okay, want to do no short. That should be fine. Now it's going to stay down until you can light up the other interface. We want to close this. So we are done with router 1. Let's now move on router 2. We want to do the same for this router config interface SA0. Now this interface is S00. That's why you want to enter, not this one right here, because that's the link you want to enable. So you do 0/0/0. You do enter. You want to do IP add. Your IP address is .2. So you want to do 10.10.10.2 255.255.252. Do enter. Okay, we are missing the IP address, so let's put address in there and we should be fine. You do enter. um, Normally you want to add a bandwidth on this interface because it's the DTE, all right, but it's not really necessary, but we're going to do that anyway. So you want to do bandwidth, you do type, you want to do 5600, okay, you do enter, and then you do no short. It should turn the interface on. Lab is good. Next, you want to work with this link between R2 and R3. So that's the link you want to work with. So this interface, that's what we're going to go in. Change state to up, line protocol is up. That is good. So let's do SE 0/0/01. Oh, okay. You do enter. Oh, I'm missing the interface. SE 0/0/1. You do enter. Next, our IP address from this range of addresses is going to look like this. The 10.10.10.4 is the network, so the next assignable IP address for /30 is .5 and .6. Okay, so we should be fine. So this interface here is going to be .5 and this interface here is going to be .6. So let's go in here and do IP add. Let me bring this over here for clarity. IP add, you want to do 10.10.10, okay, .5 255 255 255 252. Okay, you do enter. As you can see, this is also the GCE interface of this router. So we want to do clock rate. You do clock rate 64,000. You enter. Then we should do no short. It should stay down for now until we can do the other interface. So for Cisco switches, for Cisco routers, the interfaces are not enabled, unlike for the switches which their ports are all auto configuration. So basically we'll have to turn everything on the routers, unlike the switches. So you want to do SE. Now our interface we're working with on this link is this interface S000. So you want to do INTSE 0/0/0. You do enter. IP add. Our address is .6 from this network. 10.10.10.6 255 255 255.0. Sorry, 252. 255.0 wouldn't work. So it's 255 255 255 252. You do enter. You can do bandwidth, which is optional. 56 123 5600 123. Okay, I'm gonna do low short. That should turn on. Everything seems green. Love is good. Okay, and finally we want to enable the link between arrow 3 and arrow 4. Okay, so we want to stay on arrow 3 for now. So we want to do INT. Let's see, this serial interface right here, that's what we're going to be working with. So it's 0/0/0.1. You do enter. You do IP add. Now our IP address for this interface is from this network 10.10.10.8. So our first available IP address is .9.10. okay, so this interface here is going to be .9 and this interface is .10. So I want to do IP add 10.10.10.9 255 255 255.252. Do enter. On arrow 3, this link is the DCE interface. So we want to do clock rate Normally, with point-to-point links, the DC is normally set by the ISP, but since I do have command and control over my configuration, I'm just going to set my DCE. Okay, 000. That should be fine. We're gonna do no short for this interface. It's still down, and finally we are done with R3. Let's now complete the serial interfaces IP addressing on R4. This link right here will turn everything green. Next, let's do interface SE. This is the interface we are working with. All right, so 0/0/0, you do enter. You want to do IP add 10.10.10.10. okay, 255.255.255.252. do enter. Let's do bandwidth 5600, and then no short. We should be up and running. There you go. So now basically our routers can talk among themselves. If you ping from one router to another router, this should be working. Okay, there you go. So this is all functional. This is all functional, so this is how it's supposed to be. Next, if you ping from this router to this router, they should all be able to talk, but unfortunately these PCs wouldn't be able to talk to each other. The only thing that's going to allow that is a routing protocol. That's where we have RAIP, we have OSPF, we have EIGRP, and a lot of other internal routing protocols. If we're dealing with a WAN connection, we'll have maybe intermediate system to intermediate system, or maybe point-to-point protocol like a frame relay, full mesh topology, and other WAN technologies to enable routing from the internet and other WAN connections. But on the next configuration, we will configure EIGRP to have inter-LAN communications. So I'd like to thank you, and please kindly subscribe to my channel. And my name is Sadia, and I'd like to thank you once again for being a part of this beautiful configuration.